review session. For those of you who have not picked up a midterm or a regrade, the first midterm, I have it, it's all here. And yeah, I don't really have any other announcements. Everything that needs to be online, I think, is online for the second midterm. I just put up a study guide. It's not really a study guide, it's more like a list of topics. Typed it out really fast. I usually prefer to use this time that we have to distinguish the kinds of, if you have questions about the kinds of material that I'm going to test on, or the level of detail. This is really a better way to do it, but nonetheless, there's a long list of topics online now. Should we start with just general questions about what is tested or what level of detail is to be tested?
Yeah, I was just wondering if you could write a list of the pathways that you're expecting us to know, and maybe like 2 really important facts about each one, so that I can kind of get the focus or the...
Okay, sure. That's a good question. We can do that as soon as I take questions about about the process, about what's tested and stuff. Any questions about that?
So it's just about, like, I can't really see a great role prediction. Would you say just like about the level of detail and everything? Is that what we're asking about right now?
Yeah.
Okay,
I mean,
so as far as regulation then, I feel like there's a lot in there just in terms of like knowing exactly what metabolites are affected by enzymes.
well, you should be able to know like which metabolites signal energy rich and which metabolites signal energy poor. I mean, we talked about that in every regulation class. And so it should not be difficult to come up with a list of rich and poor. It's pretty obvious, really. ATP, fatty acids. A couple of idiosyncratic examples. I wouldn't expect you to remember deep details about some particular enzyme getting activated by some particular metabolite. Right? Like pyruvate dehydrogenase complex gets activated by fatty acids, maybe, or citrate or something. Right? So it would be a little bit like a detail like that would not be something I would test on. But does it get activated or inhibited by high or low energy charge? Obviously, that would be something I would test. Right? And if it was something really specific, I would probably just give you that detail and then ask you a more general question about it. Hopefully, the last exam is helpful in terms of, and first midterm in this class is helpful in distinguishing what sorts of questions I ask. Right? I really do try not to make you recall a lot of detail where it's sort of very specific to some particular enzyme or something like that. I mean, that is kind of also part of the class, right? To be able to distinguish what is, what is general and important from what is not. Other questions? I mean, the format, it looks a lot like the first midterm. There's some short answers and yeah.
For the mechanisms, are those going to be kind of essential to know the mechanisms for many of them, or is there just a select?
Well, there's no mechanisms you have to know by heart. The only mechanism you have to know by heart in the class is chymotrypsin, which is not tested, obviously, in this midterm. I mean, having said that, when we talk about a mechanism, it's just usually some specific points that I want to make on it, like how do you stabilize the carbanion ion, which we talked about 3 different times. So there's some general themes there. And so, what I would probably do is give you a lot of hints, right? If I wanted you to draw a mechanism, I would say in this enzyme there's a catalytic glutamate that abstracts a proton, and the substrate is X. And I would probably give you the structure of X unless it was one that I know that you know, like glycolytic intermediate. The only structures you absolutely have to know are the ones in glycolysis, and maybe a couple others like acetyl-CoA you should know. Malonyl-CoA, which carboxylates acetyl-CoA, you should know. Obviously, you don't have to worry about knowing the structure of NADH in terms of the details of the nicotinamide ring. In the past, I've shown the ring and given like several steps about what happens, and then I've asked to push electrons around the ring. So it's not a bad idea to look at those mechanisms and then to say, okay, I want to go from here to here. How would I draw those steps? Right? Just like 2 or 3 little electron pushings like that. And then when there's reactions that are, we don't talk about mechanisms, but, like simple nucleophilic displacements, like a mutase where there's a phosphohistidine, and then, what's the nucleophile, what's the electrophilic center, what's the product, that kind of stuff. Yeah.
For the pentose phosphate pathway, would you like us to know or be familiar with how the sugars are recycled, the pentoses to make fructose 6-phosphate?
You don't have to know the details of how they're recycled, no. You have to know that it can end up in ribose to make nucleic acids, and that in ribose you should be able to draw because it's something from last term. You don't have to worry about drawing ribulose. I mean, it goes to ribulose, and then it goes to xylulose or ribose, and then those interconvert, and then to the extent that it doesn't go off to ribose, it gets recycled. And then there's transketolase and transaldolase in 2 or 3 carbon transfer steps that eventually get you back to the middle.
Okay.
So you need to know what an aldolase and a transketolase are, what kind of carbon transfers they do. But other than that, the details of exactly 4 + 6 goes to whatever.
All right.
Wait, so like drawing structures like ribose, for example, like does it recognize other structures or draw like?
Most of them, if we haven't talked about, you need to know the structure,
Okay.
then you should be able to recognize them. I mean, if I show you coenzyme A and NADH, I mean, I presume you can tell which is which.
Yeah. Okay.
Wasn't there, like on the last midterm, identify each of the following structures is one of the problems. So I showed you the structure and asked you to tell me what it was. And then I think there was a problem where, so here's problem 5. Here's PLP. Here's there's a lysine has to do something. One of the problems in the last midterm, which is online. So stuff like that I could ask. Yeah.
Is there anything that you find normally students struggle with at this point that maybe we should pay a bit more attention to?
I don't think there's any like specific thing really. Generally, the challenge is the level of detail, like not really the level of detail. Well, maybe, but just the amount of stuff, right? Like it's just a lot of stuff. And the best way I think to go through it is to write them out, write out outlines for yourself, write out the pathways, and look for where the interconnections are. Like on this study sheet, I suggested that you might, look at which compounds get transported through membranes and where in metabolism that we've covered does that happen, and what did we say about it, right? And so you could see that it gets mentioned in several different lectures. See where the connections are, and that helps you build up the map in your head of what's going on. Yeah. Yes, sir.
The ATT arithmetic, is that something that's liable to show up?
Yeah, that could show up.
Right.
I think that ATP arithmetic is really straightforward.
It is pretty
Yeah.
straightforward. It's just saying all those.
Yeah, I mean, once you know, I mean, you should know, you should know the TCA cycle can get you 10. And, more or less how. Yeah. All right, let me answer your question, because that was good. It might be a good way to get into the reviewing. So I'll just try to write stuff out and see what happens. So you want to know, your question is about what pathways and what are the fundamental important things that are important in each pathway. So glycolysis. I'll make sure to put this online this afternoon, by the way, whatever I write down here. So clearly glycolysis is the first pathway. And in this case, you need to know the structures of the substrates. Structures of the, so going from glucose to pyruvate. So this is the only pathway that I ask you to actually be able to write them out. Okay? So that was, of course, already covered on the first midterm. So hopefully there's not a huge amount of additional review you need, but definitely, you know, go through and see that you have that. Energy, yield, and investment, clearly. The logic. So the logic basically means move the carbonyl group to C2 so that aldolase can cleave it. And then Tim interconverts the aldolase products, right? So that only one of them has to go through. So that makes the only glyceraldehyde 3-phosphate has to go forward. So that makes the pathway efficient because the other carbon product from cleavage by aldolase just gets turned into the one that goes through. Right? So that triphosphate isomerase enzyme is an isomerase that does that. That's the most important part of the lot. This part here, in the early middle part of the pathway, is the most important thing that has to do with the logic. 1, 2, 3. What is a fermentation? This isn't really glycolysis, but it's close enough. Right? So you go anaerobic, and you end up with sugar. You end up with lactate that is not in a different oxidation state anymore from the glucose. And further, you regenerate NAD.